Okay, so today we're starting operations with complex numbers. You're going to find this to be pretty straightforward. You already know how to convert from standard to complex. You know how to deal with theta, you know how to deal with radius. So we're just going to be building on that, okay? So if you guys turn to page 20. Okay, so here's the formula for multiplying two complex numbers together. That's in polar form. And it's also located in the back of your packet with the formula sheet there. Okay. But essentially, we have two complex numbers that are both in polar form, and we're going to be able to multiply them together using this formula. Basically, we're going to be multiplying the radius together, but we're going to be adding the thetas together. Okay. All right, so let's look at example 1. I'll put the formula right above it so we have easy access to it. Okay, find the product of the complex numbers in polar form. Answer in both polar form and rectangular form. Okay, so we'll multiply this because both are already in polar form. We'll combine them together and we'll use the r cosine theta, r sine theta to convert from polar to rectangular, just like how we did yesterday in class. Okay. So let me identify what we're using here. So 4 will represent the radius 1 of the first complex number. 225 is going to be theta 1 of my first complex number. Second, so this is 3 is my R2, and 90 is my theta 2. Okay, so we're just going to follow the formula here. Okay, 4 times 3. I'm going to list out every step here, but you're welcome to skip steps if you understand each of the terms I'm doing here. Okay. Theta 1 plus theta 2, I'm going to put that 225 plus 90. And then remember, there's a shortcut, right? We have a abbreviated way of saying this, 12 CIS 315. Okay, so this is my product in polar form. Now we have to convert into rectangular form here. So here are the formulas for rectangular form. R cosine theta and R sine theta. All right, so we can get it into A plus BI form, right? That's when we know that we are in rectangular form. So we pull the radius and the theta, right? We don't want to use the original R and theta anymore, right? We've already found the product, so we're going to convert this resulting product into rectangular form. 12 is the radius, 315 is the theta. .315 is a variation of 45 degrees in the fourth quadrant. We know cosine is positive, so √2/2. Sine is negative in the fourth quadrant, but also negative √2/2. So A plus BI, we have 6√2 minus 6√2 I. Make sure the I is outside the radical and not inside the √2, right? It's outside. So polar form, 12 CIS 15, and rectangular form, A plus BI here. Okay. Hopefully you guys find that to be pretty straightforward. Any questions there? Okay, try part B. Now, you're welcome to convert radians to degrees, but if they present the problem in terms of one form, you got to represent your answer in that form. Okay. So I'm just going to keep everything in radians here. Great, thank you. You can make your calculator add fractions for you. You can do 2/3 plus 1/6. Right, so that's the same thing as 4/6 plus 1/6, which is 7/6. Sorry, 4/6 plus 1/6, which is 5/6. Okay, once you get to polar form, take the additional step to convert it to rectangular form. Cosine is going to be negative in the second quadrant. Sine is going to be positive there. Okay, when you're done, we're going to talk about the other operation, which is dividing two complex numbers in polar form. Okay, so whenever you're ready, flip over to page 21. Okay, the formula is also listed at the very back of your packet too. Okay, you're going to be dividing the radius, but then you're going to be subtracting theta. Okay, does anybody still need this page? Thank you. Thank you. All right. I'm asking. Okay, you guys okay? All right, so here is the quotient or division of two complex numbers in polar form. Go ahead and copy that formula down. So it's really just, we're still involving the same forms. We just, instead of multiplying radius, we're going to be dividing. Instead of adding the thetas, we're going to be subtracting. Okay, go ahead and try number 3. You should be able to just do a similar process from the previous page. You're just adapting to a slightly different formula because you're dividing the complex numbers instead of multiplying. Okay, great. Thank you. Okay, convert to rectangular form after this. Zoom in a bit here. Okay, cosine is negative in the second quadrant. Okay, try number 4. Okay, remember for number 4, dividing by a fraction is the same thing as multiplying by the reciprocal, right? But you can also make the calculator do the complex division if you want. Okay, everybody okay with number 3? Okay, here's number 4. I'm still working through the rest of it. You can always add 2 pi or subtract 2 pi if something doesn't feel familiar. Okay, check my work. Is that what you guys got? Okay. Mm-hmm. Oh, okay, sorry about that. Yeah, let me change that. It should be sign. Yeah, just happens to be the same value because it's power 4, but yeah, it should be sign. Yes. Okay, let's go to page 22. Let's see, for classwork, guys, for classwork, we're just going to do 1 through 6. Okay, so 1 through 5 on page 22, and we'll do number 6 on page 23. Okay, so there's a mixture of multiplication and division. We're just going to practice through. 1 through 5 on page 22, and then just number 6 on page 23. So we'll just do 6 problems. Okay. If a problem is presented in degrees, then represent your answer in degrees, well, at least the polar form in degrees. And then if it's radians, then keep it in terms of radians, okay? And I'll work through as you guys are working through as well. Okay, if you're able to get to your answer in shorter steps, that's fine with me. I just want to show every step along the way. But you can definitely, once you get comfortable, you can move through faster if you like. Okay. Okay. Great. Thank you. Okay. Speak up if you see something that I messed up on, but just check my work as you guys are working through. Okay, number 3, we're changing it up to a division problem, right? Number 3 is divisional. Oh, they say to present your answer between 0 and 360 and also between 0 and 2 pi. So if you see a negative radian or a negative degree measure, you got to add 360 or add 2 pi to get your polar form in that range. Okay, we're going to see that with number 3. You got to make some adjustment to get that polar form to be in the range. Okay, it didn't specify on page 21, but for page 22, it is specifying that the range for values for radians and degrees. Oh, thank you. What's the question here? Okay, because the top of the page says present the radians between 0 and 2 pi. So this is outside the region, so we can always add 2 pi to get it in the proper region. Number 5, going back to division. Okay, one more, number 6 on page 23. Division again. I'll put number 6 up in a minute.
Okay, sir.
Okay, is everybody okay with number 5? Okay, I'll come around and check pages 20 through 23. Let me check those 4 pages in about 5 minutes, okay?